I've got a work in progress on hacking Smartwater wireless water meter networks. My interest in this comes out of my history in non-IT circles. I've been a water commissioner for 13 years in Massachusetts. I also worked for a nonprofit, Clean Water Action, helping citizens protect water supplies. So I probably have more of a water-centric view on this first than a tech-centric. But I've been an IT pro for 5 years, mostly doing tech support. I've done articles in the New England Water Works Association Journal on water infrastructure. And this talk comes out of the talk I gave at DEF CON on cyber terrorism and the security of the national drinking water infrastructure, which got interest only in Japan. The Japanese press thought it was interesting. It was cited in an October issue of Asahi Shimbun, if I'm pronouncing it correctly, the big national in Japan. And it'll be in next month's Hacker Japan. They're doing a feature story on it. As I said, it's a work in progress, so there's a lot of incompletes in here. I haven't actually hacked anything. Sorry if I led anyone to believe otherwise, but I'll tell you about what I've been putting together to get to that stage. And hopefully if I have it in good enough shape, I'll be presenting it at DEF CON 19. We'll see. We know the electricity smart grid can be hacked. There was a presentation at Black Hat 2009, IO Active. Joshua Wright's done a lot of work on Zigbee. There's a Dartmouth group speaking later today about hacking Zigbee. And there's a lot of attention and information on hacking the smart grid or vulnerabilities with the smart electric grid. Not as much on the water grid. I talked to the director, the guy running the smart grid LinkedIn page, and he thinks I'm the only one working on the water smart grid. And I hope I'm not the only one working on it, but I'm the only one that I know about. So we're going to look at the water smart grid and see what the story is. Now, a nominal water system, and this is a short talk, so I'm not going to go into great detail, but it's got a water supply, it's got water storage, it's got treatment, it's got distribution, and then there are there's a network in almost all systems these days connecting them together. So there are sensors at the reservoir, there are sensors at the treatment facility, of course, where the heart of the SCADA system is. There's sensors at the storage tanks. Overall, the national story is there are about 150,000 water systems in the US. They're not connected like the electric grid is, and they're heterogeneous, meaning they're very different. Most of them are one-off systems designed specifically for the water supply in the locale that they're in, which makes it interesting if you're trying to come on from outside without local knowledge and trying to hack into it. You have to know not only the electrical and the cyber connections, but also what is the hardware and software in that plant. And that's often very hard to do even if you're working in the plant. Drinking water is a critical infrastructure. And this is a topical subject even if water systems aren't likely to be hacked today or in the future. It's part of the critical infrastructure that since Stuxnet came out and put that on the table for hacking and for cyber intrusions, water is one of the more important critical infrastructures that need to be protected. Water systems have been a target of attack for terrorists for centuries, and Al-Qaeda has repeatedly said that they threaten to poison the US water supply. Whether they can do that, they or anyone can do that or not is still a question. The most likely physical attack scenarios that I identified in my DEF CON talk aren't contaminating the reservoir, aren't doing anything in the treatment plant. The storage tanks are plausible because they're after treatment and they're usually not watched. There's usually not eyeballs on them all the time. But most experts conclude that the most likely scenario is the distribution system. Then, of course, you're not talking about a national attack everywhere. You're talking about specific attacks after somebody studied the distribution system. So you can get into the distribution system through two main routes: the hydrants, the fire hydrants that are supposed to be about every 1,000 feet on a distribution system on the pipes, or any residence or structure attached to the system. And there have been studies on this in the American Water Works Association Journal by the Navy, by the Armed Forces, that conclude that if you've done a distribution study and you have some idea of the hydraulics of the system, that you can pretty much engineer that if you put X amount of a contaminant in a hydrant, X amount of distance from a target location, And that's usually how this works. You're not trying to necessarily poison the entire water supply, but you're trying to target a building, a critical building, which in DC, for example, there'd be a lot of those that would be potential targets. That would be the way to do that. If you had better understanding of the hydraulics of the system, you could potentially try to contaminate the entire distribution system. Then, of course, you'd have to have some idea of the hydraulics and the speed of the water and the flow and the volume to really understand what the contaminants would be at the end. So I know from working in a water system for 13 years that even the people running them don't always know the hydraulics of them, and you can't guarantee that if water goes in one place that it's going to come out the other end the way that you expect it. There are valves that are broken. There are valves that are open strangely. There are clogged pipes. There's all sorts of things that can happen that aren't apparent from the distribution system map. But this is a realistic concern that's been pointed out by military experts for military bases especially, and there's a number of countermeasures that can be taken. So let's talk about cyber attack, other vectors for cyber attack. Flash drives was mentioned earlier, laptops, Stuxnet, of course, through laptops or flash drives or through the internet. Stuxnet, as we know, was targeted for the Iranian nuclear plants, but a Stuxnet type attack is being thought of now as a potential vulnerability for all critical infrastructures that run on process control systems. But water systems have been attacked through laptops. Harrisburg system was attacked through malware that got into the SCADA system through a laptop in 2006. The other big story everyone hears about is Marucci in Australia, that in 2000 a disgruntled former consultant who had knowledge of the system used his laptop to enter into the wireless system for the pumps and pumped about 800,000 gallons of sewage into the waterways. So it's possible. But those two examples, and there's a handful of other ones, but the fact that there's a handful of them tells you, one, it can be done, but the fact there's only a handful tells you that it's not really something that's very prevalent. So the long and the short of it is that, cyber or physical attacks on water systems are plausible. There needs to be something done about them, but they're not necessarily the top priority for security experts. The wireless department network I mentioned, and the wireless water network is the one that I'm trying to put some thought into. So what is a water meter? We all know what a water meter is. I cut and paste this from Wikipedia. We don't really know about the different types of water meters. The bottom line is that whether they use displacement or velocity, they're detecting obviously the volume of water that's passed through the meter. And one reading, of course, doesn't do you any good. You need to compare it to an earlier reading so you can subtract them and find out what's passed between the first reading and the next reading. So the interesting thing is wireless water meters. Almost every water meter made today translates the information into an electrical signal. So even though if it has a dial on the front that shows you, the increasing volume that's gone through the meter, there are 2 or 3 wires in it that can be attached to a radio, basically, a radio transmitter, and make it wireless. The bottom line is there's no standards. While if you're installing a wireless add-on to a water meter, it obviously has to be compatible with the installed water meter. And either it can be the same manufacturer, or a lot of manufacturers make some that are compatible with a lot of ones on the market. But you can see from the pie chart that there's a lot of different ones out in the market. And it's really a free-for-all out there. There's a hodgepodge of older meters in the 150,000 water systems in the U.S. Some are more compatible than others with various vendors for wireless water meters. And if you're running a water system, it's really difficult sometimes. You can't just snap your fingers and say, we'll use this one. You have to do a study and make sure that they're compatible. The way to read a meter goes from pre-wireless to wireless. Obviously, the first way is eyeballing. You have people drive out in trucks. They walk out. They go inside the house or the meter pit, and they read the meter, write it down, go back, report it back. That costs a lot of money. 60% of the water systems are probably doing just that. They're moving toward wireless systems. The next step up is handheld reader. We call it a gun, which is a handheld computer. And you put it on the two wires or the contacts on the top of the wireless water meter, and you read it. It stores the information, and you download it back at the water plant. Then there's drive-by, where there's actually a wireless transmitter on the meter, and it's got enough of a range so that you can just drive by the house, and the collector connected to a laptop in the car will automatically give you the data. The full implementation of a wireless water meter system is called fixed network, where the range of all the systems are enough that either through repeaters or directly to the central collector, they get all the data. The data doesn't have to be wireless radio transmissions. It can be phone lines. Some are building on the existing electric grid systems. Cable, though that's not as much used as you'd think, even with the large amount of cabling for infrastructure in the U.S. Power lines, that can be done, but it's problematic because of the high volume of voltage in the power lines. Radio frequency is the major way that it's done. In Washington, D.C., they're one of the first metropolitan areas in the U.S. to go fully wireless back in early 2000s, and they have wireless meters on the wireless add-ons on the meters that go to a central collector that then sends a